Next question. Given below are two statements. Statement 1. The family n of theta comma 1 such that theta is equal to 1, 2 of certain normal distribution is not complete. Statement 2. The family n of theta comma 1 such that 0 less than theta less than 1 is of certain normal distribution is complete. So we have to see which among these statements is true or false. So the first one we can see n of theta comma 1 where theta is equal to 1, 2. And second case it is between 0 and 1. So we have already learned that the range of theta between 0 and 1 will be a complete normal distribution, then the other one will be not. So we can see the first option is the right answer, that is both statement 1 and statement 2 will be correct. Moving on to the next question. Let x1, x2, etc. xn be an IID random variable with a density function f of x theta is equal to theta divided by x power theta plus 1, x greater than 1 and theta greater than 1. We have to find out the estimator of theta based on the method of moments. So we have already learned what is method of moments, and if we read the question properly, we can see that there is only one parameter we have to estimate. So we can take m1 dash is equal to mu1 dash and equate. So since the density function is already given, we can find out the mu1 dash from that, and m1 dash will be equal to 1 by n summation xi, that is x bar. So from that we will get theta bar is equal to x bar divided by x bar minus 1, that is option 1 will be the right answer. The theta cap using the method of moments will be x bar divided by x bar minus 1. Again, we have two statements here. Statement 1, if Tn is consistent for theta, then Tn plus 1 by n is also consistent for theta. And statement 2, if Tn is consistent for theta, then g of Tn is consistent for g of theta, where g of theta is a linear function of theta. So we have to see which among these statements are true or both are true or not. So first one we can see if Tn is consistent for theta, Tn plus 1 by n is also consistent. We can see that that is true because if Tn is consistent, Tn plus some constant will be also consistent for theta. So statement 1 is true. Now we will see the second one. If Tn is consistent for theta, g of Tn is consistent for g of theta, where g of theta is a linear function. So if we are applying a linear function to the consistent function, then g of Tn will be consistent for g of theta. That statement is also correct. So the option 1 is the right answer, that is both statement 1 and statement 2 are true. Next question. Let x1, x2, etc. xn be independent and identically distributed, that is IID, uniform 0, theta, where theta greater than 0, random variables, and x bar is equal to 1 by n summation I equal to 1 xi. Then we have four statements, that is first one is x bar is sufficient for theta, minimum of x1, x2, etc. is sufficient for theta, maximum of x1, x2, etc. is sufficient for theta, and 2x bar is sufficient for theta. So all the four statements are based on sufficiency. So sufficiency we can simply say that according to Neyman factorization theorem, if x1, x2, etc. Xn given theta, if we can factorize it to g of t given theta into h of x1, x2, etc. xn, then we can say that the given parameter is sufficient. So using these theorems, we can see that the third option will be the right answer, that is maximum of x1, x2, etc. xn is sufficient for theta. Moving on to next question. Let the random variables x have binomial distribution with the parameter 3 and theta, that is x is going to follow binomial distribution with the 3, theta. A test of hypothesis h0 such that theta is equal to 3 by 4 against h1 such that theta is equal to 1 by 4, and we reject h0 if x less than or equal to 1. Then the test has given 4 options, that is we have to find out the size and power of the test. So simply we can the null hypothesis and alternative hypothesis is given. So using that we can define the size and power. So first we will find out the size, that is size is equal to probability of reject h0 when it's given that h0 is true. So we can write it as probability of rejecting h0 if x is less than or equal to 1 is already given in the question. So x less than or equal to 1 given, x less than or equal to 1 given, h0 is true. So h0 is true when theta is equal to 3 by 4, that is theta is equal to 3 by 4. So we can see x less than or equal to 1 means probability of x is equal to 0 plus probability of x equal to 1 given that theta is equal to 3 by 4. So since x is following binomial distribution, we have NCX e raised to x q raised to 1 minus x. So in that we are going to substitute the values. Theta is equal to 3 by 4 and finally we will get the answer for size is equal to 5 by 32. So we will see among the options where size is equal to 5 by 32. So we can clearly see that option 1 will be the right answer because all other values are different for size. But still we are going to check whether power is equal to 27 by 32 or not. So we have power is equal to 1 minus beta, which will be equal to probability of rejecting H0 given that H1 is true. That is equal to probability of x1 less than or equal to 1 given that theta is equal to 1 by 4. So again we can substitute the values of theta into the binomial distribution equations and find out, and finally we'll get the answer as 27 by 32. That is option 1 will be the right answer. So next question, let x have a density function f and the distribution function capital F. If density function is symmetric about 10 and capital F of 7 is equal to 0.3, then probability of 10 less than x less than 13 is. We have already seen a similar question in this question paper only. We can see how to prove it. That is, given that f of 7 is equal to 0.3, which is equal to probability of x less than or equal to 7. And it is given that f is symmetric about 10. So probability of x less than 10 will be equal to 0.5 or equal to 1 by 2 we can write. So using this, and since it is symmetric, we can write probability of x greater than 10 will be equal to probability of x less than 10. So now we are going to consider the term that we have to find out, that is probability of 10 less than x less than 13, which will be equal to probability of x less than 13 minus probability of x greater than 10, or simply we can write probability of x less than 13 minus probability of x less than 10. Now we have the value for x less than 10 and we have to find out the value for x less than 13. So since it is symmetric, we can write probability of x less than 13 is equal to 1 minus probability of x less than or equal to 7, which will be equal to 0.7. So since we know all the values, that is probability of x less than 13 and probability of x less than 10, we can substitute those values and find out the probability of 10 less than x less than 13, which will be equal to 0.2. That is option 1 will be the right answer. Next question, let f naught x is equal to 2x if 0 less than x less than 1 and 0 otherwise, and f1 of x is equal to 1 if 0 less than x less than 1 and 0 otherwise. And the null hypothesis is f of x equal to f naught of x, and the alternative hypothesis is f of x equal to f1 of x. If the size of the most powerful test is alpha, then power of the test is. So similar question we have seen previously before 2-3 questions only. We have to find out the power of the given test and the size is given as alpha. So we know that power is equal to 1 by beta, which will be equal to probability of reject H0 given that H1 is true. So we can substitute the already the f0 x and f1 x is given. We are going to H1 is true means f of x is equal to f1 x. That case we are going to consider, and we will get the power of the test as option 3, that is alpha raised to 1 by 2 will be the right answer. Let x have the mass function p theta of x is equal to theta equal to 1, 2 and x equal to 1, 2, 3, 4. So corresponding to x equal to 1, 2, 3, 4, we have p1 of x and p2 of x given in the question. The critical region of the most powerful test of size is 1 by 4. To test h0 theta equal to 1 against h1 theta equal to 2 based on the single observation is, that is, the size of the test is given as 1 by 4, that is alpha is equal to 1 by 4, and we have to find out the critical region. We can consider it as lambda x. So lambda of x we can write it as p2 of x divided by p1 of x. That will be the critical region based on one single value, that is p2 of x divided by p1 of x. So lambda 1 will be equal to 1 by lambda divided by 1 by 4. Lambda 2 will be equal to 5 by 11 divided by 1 by 4, etc. We can find out the values. And if we go on see the lambda 1, lambda 2, etc., we can see the set x such that lambda of x greater than k will be the critical region, and the answer will be option 2, that is set 2 will be the right answer. Let H naught such that probability of x equal to x equal to 1 by 10 for x equal to 1 to etc 10, and H1 such that probability of x equal to x by 55 for x equal to 1 to etc 10. The critical region for the most powerful test of size 0.2 is again a similar question, that is size is alpha is given as 0.2, and we have to find out the critical region for this given question, and the answer will be option 4, 9, 10, set 9, 10. Since we have already discussed many questions related to critical region, size, power, etc. I am not again explaining this how to do. Answer will be the fourth option. The degrees of freedom for the error in 2 square factorial experiment with R replications will be. So we have seen 2 square factorial experiment, that is 2 factors each having 2 levels. So its degrees of freedom, this is a direct question. Degrees of freedom with R replication will be option 1, that is 3 into R minus 1 will be the degrees of freedom. So option 1 is the right answer. Consider a sample of size n drawn from the population of size n, capital N, under simple random sampling without replacement. Then the probability that a specified unit is not included in the sample is. So again we have a direct question. These under sampling distributions we have discussed these things clearly, and the answer will be third option, that is 1 minus small n divided by capital N. This will be the probability that a specified unit is not included in the sample, where small n will be the sample size and capital N will be the population size. In a completely randomized design with the T treatments and n experimental units, the error degrees of freedom is equal to. So for a completely randomized design, if you are drawing an ANOVA table, we have sum of squares and degrees of freedom only we are considering. So first one will be treatment, then will be error, and we have the total. So here it is given that there are T treatments. So the degrees of freedom related to treatment will be T minus 1, and there are n experimental units. So the degrees of freedom for error will be n minus T, and the total will be n minus T into T minus 1. So the answer is n minus T, fourth option. The degrees of freedom for errors will be n minus T. Now, the method of confounding is a device used to reduce the size of which among the following options. So directly we can see that experiment and experimental units is not going to affect with the method of confounding. So the correct answer will be option 1, blocks. So we have already discussed the method of confounding, factorial experiments, etc. everything under the unit designs of experiment. So this question is from the design of experiment, that is method of confounding, and it is going to reduce the size of blocks. This much is about the questions related to statistics under the question paper CUET 2022. So while looking at all the questions, we can see that only a few questions are direct and many other questions are related to some mathematical calculations or indirect questions are there. So if we read the question carefully only, we can understand how to work on that question. So learn every questions properly, and all the best. Thank you.